Okay, so for this next one, it says one customer had an unusual request. She wanted a block that is extended 2 inches on one side and decreased 2 inches on the other. So one of the employees thinks that this rectangle will have the same area as the original square because you're adding 2 and minusing 2, right? So what do you think? Use a diagram to find two expressions for the area of this block, okay? And so I was peeking at what you guys were doing, which I saw some awesome work. And then so I got this work right here that says x plus 2 and x minus 2, right? So then they multiply it out and it's x squared plus 2x minus 2x and minus 4. And then they wrote it all out. And then they noticed that plus 2x and minus 2x, it cancels out. She says, is that right? And I'm like, yes, this is exactly right. So let me clip this. Where's my, there it is. Let me clip this so that you guys can all reference this later. So copy and then paste over here. This is number 9. And then they're going to ask you like, hey, is there a pattern that we've noticed, right? Is there a pattern we've noticed for this one? So here it says the results of the unusual request made the employee curious. Is there a pattern, a way to predict the two expressions? So the first thing that I want you to do is tell me, what is this? What do you notice over here? What do you notice over here? Yeah, these are opposites, exactly, right? X plus 1 and x minus 1, these two numbers right here, minus 1, plus 1, those two are opposites. So that's the first thing. So if I see opposites, right, what pattern did you guys start seeing? Yeah, so this person says x squared minus 1, x squared minus 9. This person said the same thing, x squared minus 1, x squared minus 9. This person said the same thing. Do you see a pattern? Is there like some kind of pattern? So for example, here's another person. They wrote all that out. Wow, look at all this work. Okay, so they noticed this pattern. The pattern I notice is that bx minus the number is being subtracted with its full equation that comes up after, and it doesn't have a bx for both equations. So these two, this person's kind of saying it like this. These two numbers keep canceling each other out, like the previous slide that we looked at. Someone's like, canceling out, Miss Johnson? Yeah, these are canceling out each other. They're equal to 0. So if I see opposites here, x plus 3, x minus 3, I can use the little pattern shortcut that I just came up with. I can kind of use that pattern shortcut that I just kind of came up with. Okay, so if you really get this, right? If you really get this, what would this one be? Number 11 says, what pattern did you notice that will result in x plus a times x minus a? What would this equal to? What would I write on this side? Thinking about this over here, what would I write for this side? Because remember, those little guys cancel, right? Like, for example, how about this? If I asked you this, what if I put x plus 7 and x minus 7? Okay, those are opposites. What would it equal to down here? What would it equal to? So it would be equal to, very good, this x squared right here, very good. So it's x squared, good, right? Yeah. What happened to the 7x and the negative 7x? What's going to happen to the 7x and the negative 7x? Someone put in the chat this right here. They put this in the chat. Let me grab it real quick. They said, hey, Miss Johnson, it's just going to cancel out. I'm just going to write it right here. It's x squared minus 49 because they cancel out. The 7x minus 7x, they cancel out. So this pattern here, I know this is going to be a stretch, but let's try this. What's x times x? Well, that would be x squared, right? Oops. That would be x squared, right? And can you imagine those two terms, these two terms right here, canceling out? Right? And then it would be minus, and wait, where'd you get this 49 from? Where'd you get this 49 from? Where'd you get this 49 from? Yes, 7 times 7. Okay, so then what would go here? If it's x plus a and x minus a, what would it be? X plus a times x minus a, it would be x squared minus, for this one right here, what would we put? X squared minus? Yeah, I know, it sounds weird. A squared. Jonathan, what? Wait, first let me make it look more mathy. Hold on a second. Let me make it look better. Okay, so first, where, like you told me that it was 49. And 49 came from 7 times 7, right? So I could literally write it like that, 7 squared, 7 times 7, right? Right? So I know that looks weird, x squared minus 7. Ms. Jonathan, why wouldn't you just put 49? Because I want you to be able to look at it like this. Do you see x squared minus a squared and x squared minus 7 squared? Same thing. Very, very good. Very good. So maybe this is one of those shortcuts that you can use. Okay.